The next couple problems are like puzzle problems. So take a look at the first one that we're going to work on. Example 3. It says a drawer contains 10 black and 10 white socks. You may reach in and pull some without looking at them. What's the least number of socks that you must pull out in order to make sure to get a matching pair? Okay, so pause the video and think about that for a second. How many socks do you have to pull out of a drawer so that you can have two that match? Now, many students want to answer 11 because they're thinking 10 black and 10 white. So they are thinking, let's say 11. But the real answer is actually 3. Think about it like this. What could happen here? Okay, so when you pull the first sock out, there are two options. It could be either black or it could be white. Okay, so let's say on this day, your first sock that you pulled out was black. Then you have no matching pair, so you're going to continue and pull the next sock. If it's a bad day, you're going to end up pulling a white sock. And so far, you don't have a matching pair, so you have to go back and pull another third one. And the third one could either be black or white. If it is black, then the first and the third are going to match, and that's it. You now have a matching pair. Now, if you're unlucky and you get a white one, then the second one and third one will match, and now you have a matching pair. So I only had to do 3 socks to get this outcome. Now, if on the first try you end up with a white sock, and you pull the second sock and it was actually black, that's the worst thing that could happen. Well, you don't have a matching pair, so now you have to go back and pull a third sock. And what could happen with the third sock? If it's already white, then it's going to match the first one, so that means we have a matching pair. But if it's black, then it's going to match the second one. Either way, you have a matching pair. Okay? So again, it does not matter what the third sock is, it has to match with something that already existed, regardless of what you pulled out, basically. Okay? So the real answer to this question is actually 3. All I have to do is pull 3 socks out in order to get 2 matching pairs. Okay, why does this happen? So basically what's going on here is we have a function that is pretty much pulling a sock out and assigning a color to it. There are only 2 colors, right? So basically there are either black socks or white socks, and your function has 1, 2, 3, 4, actually 20 socks in the drawer. So the first socks get pulled, it's going to be either black or white. The second sock gets pulled, let's say it's the worst case scenario, and you get a white one. Okay, now what's going to happen with the third and the rest of them? The third sock that you pull out has to be either black or has to be already white. So regardless of which choice it is, it's going to have to match some other sock that you already have determined, right? So, you know, if it matches with the black one, then it's exactly like the same as the first sock. If it matches with the white, then it's going to be exactly like the second sock, and you now have a pair of matching socks. So the answer is 3 socks are needed because n is 20, there are 20 socks, 10 white and 10 black, and m is 2 because the colors can either be black or white, okay? So since 20 is bigger than 2, the pigeonhole principle applies. So in this problem, the function assigns a color to each sock that you pick at random, okay? So as you can see, the functions in this section are kind of abstract and weird. They're not just taking a number and giving you a number. In this case, they're taking a sock and assigning a color. So it's not the traditional kind of function that you're used to working with in calculus and before, okay?